Example 5, verify that this is equal to that. Okay, so we start with the more complex side, which right now I'm not really sure. Now you can see up here that it says verify by working each side separately, but you won't always have that information. So I'm going to start, and we'll just say, let's go to the left. We're like, I could factor that. Well, if I take out the factor of cotangent by GCFing, that's the greatest common factoring, I would see that I could take out a cotangent x, and I'd be left with here. I take out 1, and I'm left with 2, or cotangent squared. And here, when I divide cotangent by cotangent, I'm left with 1. Now, when I check this, this looks like Pythagorean. I got cotangent squared and a 1. So I go to the formula chart, and I look for cotangent, and here it is. It says cotangent squared plus 1 is equal to cosecant squared. So I'm going to go over here next and say, all right, I think I'm going to do Pythagorean. And so this becomes cosecant squared x, while the front stays the same. Now I understand this says work each side separately, but here's what you might understand. You might figure out to try, but you can see they're kind of close. The one thing you don't actually have to work each side separately if you just know to use what's called quotient, the quotient identity. Now the quotient is that you turn this, the tangent or cotangent, into division. So psi y cos x, tangent is y over x, which means cotangent is x over y. This is the same thing as cosine x over sine of x. I'll write the red here. Now, if you're confused, it's okay. Just go back over here and follow the instructions to try this side. Well, now, as I look to the right, there's no fraction. So I think, how do I get something off the fraction? Well, I'm going to do a reciprocal. So I want to move sine up. Now, if I'm going to move sine up, I need to know it's reciprocal. So I'll write reciprocal over here because that's my next step. Let's go look on the formula chart. The reciprocal identity for when sine is in the denominator is here. It becomes CSC. So I can say if that comes up, the cosine stays the same, so I'll keep it in blue so you're not confused. The sine, though, comes up to the top. It's no longer in the denominator. It now becomes the numerator, and it becomes its reciprocal, which is CSCx. And this will multiply times CSC squared x. And now we can see why we get the answer. When I simplify this, I would have cos x times CSC to the third power. There's 1 times this squared. It becomes that. That's what we want it to be. And so we verified that this is, in fact, true. Now here's one for you to try.